Here we've got bicyclists riding in a circular track, or around a circular track. So here's our circular track. Here's the bicyclist. Okay. Says he's got a tangential speed of 13.2 meters per second. We know the magnitude of the centripetal force is 377 newtons. And we know the combined mass of the bicycle and the rider, so the mass of what's happening on that bike, is 86.5 kilograms. We want to find the radius. Okay, so we want to find this length here. Okay, sorry it's so blurry. So we know with Newton's second law that our centripetal force would be equal to our mass times our centripetal acceleration. We know that centripetal acceleration is equal to our tangential speed squared divided by the radius, so we can rewrite Newton's second law as Fc is equal to mvt squared over r. Okay. Here, remember, I'm solving for the denominator on one side so I can swap it with the numerator on the other and get r is equal to mvt squared over Fc. But again, just as easily I could have done the radius and multiplied radius out and then divided both sides by centripetal force. And that would give me the same thing I have over here. Alright, so now I've got my radius. I know my mass, I know my tangential speed, I know my centripetal force. Everything is in the correct SI unit, so I'm going to go ahead and plug and chug. So I'm going to do my mass of 86.5 kilograms, multiply it by my tangential speed. However, I'm going to square my tangential speed first, so let's go ahead and put brackets here. 13.2 meters per second squared. Take this value times m, and divide that by my centripetal force of 377 newtons. However, instead of newtons, I am going to go ahead and write kilogram meter per second squared. Alright, for my numerator, I've got 86.5 kilograms times, let's go ahead and figure out what this term is here. So 13.2 squared is 174.2, and it's going to be meters squared per second squared, all divided by 377 kilogram meter per second squared. My numerator now would be 86.5 times 174.2. So 1.5 times 10 to the fourth. And now it's going to be kilogram meter squared per second squared. I'm going to take this and divide it by 377 kilogram, that's a 7, meter per second squared. If I'm dividing these, I see that my kilograms will cancel, my second squared will cancel, and one of my meters will cancel, leaving me with just meters, which is the correct unit for a radius. Okay, I'm going to go ahead and do this value here divided by 377, and I get 40. Okay, so 40 meters should be the radius of this track.